Okay, we are on section 2.7, inverse functions. Okay, now guys, an inverse function is, we've been kind of talking about inverse functions when we deal with taking the square root of a square. And remember, I tell you they kind of cancel each other out. The inside falls out, or we square a square root, okay? Those are inverse functions. So today we're going to talk about being able to find the inverse function, or finding the inverse of any type of function, okay? So that's the first thing we need to do. And it's pretty simple, guys. There's not much to it. You just kind of follow the rule and you're good to go. To find an inverse of a function, simply switch the x and y values. Then solve for y. Okay? We denote the function itself, of course, as f of x. And then we will denote its inverse as f with a little minus sign at the top, x. Okay, and that is the inverse of f of x. Okay, Ben is here. Who else came in? Ben came in. Who else came in? You're, Esmeralda? No. Yes. Okay. Let's look at example 1. Find an equation for the inverse of f of x. And we write out what it means right here, the inverse function of f of x. Okay. And we have a few parts, A and B, just a couple. And we start off with f of x equals 3x minus 1. And they want us to find the inverse of that function. Okay? So, step 1, what we're going to do is we're going to change f of x to y. Okay? Because remember, f of x is the same thing as y, right? And to find an inverse, we switch x and y. So we're going to turn this into y equals 3x minus 1. Then we're going to switch x and y. And all that means is everywhere I see an x, I'm now going to put a y. And everywhere I see a y, I'm going to put an x. So this is going to become x equals 3y minus 1. Okay, now we're going to solve for y, which of course means get y by itself on one side. Okay, so I'm going to add 1. That's going to give me x plus 1 equals 3y. Divide both sides by 3. And I pretty much have y equals x over 3 plus 1/3. And our last step, change the new y to inverse of f of x. You can't see that good. Okay, so now I'm just going to take that y and I'm going to turn it into the inverse of f of x equals x over 3 plus 1/3. And that's your answer. Okay. So look at B. B says f of x equals x plus 2 cubed. Okay, first step, change the f of x to y. So y now equals x plus 2 cubed. Now we need to switch. That's okay, go ahead. Now we need to switch x and y. X equals y plus 2 cubed. Okay. Let's take, now, we got to get y by itself. How do I get rid of the cubed? Take the cube root of both sides, right? We need to get that y out of that cube. Okay? So the left-hand side is going to stay the cube root of x equals, now, when I take the cube root of y plus 2 cubed, the inside just falls out. That's going to give me y plus 2. I'm going to subtract 2 from both sides. That's going to give me cube root of x minus 2 equals y. Okay, you're good to go. Now you're ready to switch that y back to, that's your new y. You're ready to switch that back to the inverse of f of x. So inverse of f of x is going to equal the cube root of x minus 2. Good job. Oh, we have a c. I'm going to put c beside it right here. I'm going to make him go up a little bit higher though, so I have enough room. C, we have f of x equals x plus 5 over x minus 6. Okay, change f of x to y. Y equals x plus 5 over x minus 6. Okay, now I've got to switch my x and switch my y, right? So that's going to give me x equals y plus 5 over y minus 6. Okay, now I got to somehow get those y's on one side together, everybody in the top, right? How do I get rid of something in the denominator? What do we say do? We got to multiply by it, right? So I'm going to multiply this whole thing times y minus 6. Okay. So that means the left-hand side is just going to, I'm just going to write it x times y minus 6. Okay? I'm not going to overcomplicate it. Now on the right-hand side, that's the reason I multiplied times y minus 6 is to get that y minus 6 out of the denominator. So that y minus 6 in the numerator and the 1 in the denominator, they divide out and make 1. They cancel and make 1. Okay? So that's going to leave me with y plus 5. Things are looking better. Okay? No more fractions. All right, now I need to distribute that x. Okay? So that's going to give me xy minus 6x equals y plus 5. This actually does look better. Okay, we need to move the y's all to the left-hand side, move that negative 6x to the right-hand side. So I'm going to add the 6x first. That's going to give me xy equals y plus 6x plus 5. Now I'm going to subtract that y over, so I have everybody on, all the y's on one side together. And that's going to give me xy minus y equals 6x plus 5. Now if you'll notice, xy and minus y both have a y in them, right? So we can factor out a y. That's going to leave me x minus 1. Because guys, think about it. Y times x is xy. Y times negative 1 is negative y. Okay? Equals 6x plus 5. I'm going to divide both sides by x minus 1. And that's going to leave me with y equals 6x plus 5 over x minus 1. I need to change my y back into its inverse sign. So I have the inverse of f of x equals 6x plus 5 over x minus 1. Okay. All right. We good? We got this? You good, Drake? Okay. Okay, to prove that two functions are inverses, we need to find the composite of both of them, the composition of both of them. So f of g of x has to equal x, and g of f of x has to equal x. So what they're going to do, and you'll see in the next example, is they're going to say determine if the given functions are inverses of one another. So what we have to do is we have to find f of g of x, then we have to find g of f of x, and both times they have to come out with just x left over, okay? Now, that's why we did a whole find the composition of two functions, okay? So in example 2, we have determine if the given functions are inverses. A gives me f of x equals the cube root of x minus 4, and g of x equals x cubed plus 4. So what we're pretty much asking ourselves is, okay, does f of g of x equal x? And does g of f of x equal x? You got to do both of them. They both have to equal x. The only way we don't have to do both of them is if the first one that we get, he doesn't equal x, then you can ditch it, because it's like, okay, they both have to come out equaling x to be inverses of one another, okay? So let's start with the first one. Let's find f of g of x. Okay, so I start off with normal f of x. I have f of x equals x cubed, equals the cube root of x minus 4. Sorry about that. And I'm looking for f of g of x. Okay, so what happened? Everywhere I saw an x, I'm going to plug in a g of x, right? So this becomes the cube root of g of x minus 4. There was an x, I put in a g of x. Now, I actually know what g of x equals, right? They told me what g of x is. G of x equals x cubed plus 4. So, that means f of g of x equals the cube root of x cubed plus 4 minus 4. Okay? So I've got f of g of x equals the cube root of x cubed plus 4 minus 4. Well, plus 4 minus 4 gives me 0, right? So f of g of x just equals the cube root of x cubed, which is going to give me x. So the first one checks out. F of g of x equals x. That's what we were looking for. Now we got to check the other one. In order for them to be inverses, g of f of x has to equal x also. Okay? So this time we start with, well, what did they tell me g of x was? They told me it was x cubed plus 4. Okay? I'm looking for g of f of x. So everywhere I see an x in g, I'm going to plug in f of x. Okay? So this is going to become f of x cubed plus 4. Well, what's f of x? F of x is really x cubed minus 4. So g of f of x is going to equal the cube root of x minus 4 cubed plus 4. Okay, that means that g of f of x, well, if I'm cubing a cube root, that's going to give me x minus 4 plus 4. Inside falls out, right? So I get g of f of x equals x. So we got f of g of x equals x, and we got g of f of x equals x. Okay? So we can say that f of x and g of x are inverses. Okay, let's do a B. B, they ask me the same thing. They go, it's still example 2, determine if the given functions are inverses. And B says f of x equals 3x minus 7. G of x equals x plus 3 over 7. Okay, so we start out just like we did. And we want to find f of g of x to start with. Okay? All right. So what does f of x equal? Yep, 3x minus 7. So what I've done is everywhere there was an x, we're putting in g of x. Okay? So f of g of x is going to equal 3 times g of x minus 7. Okay? Well, what does g of x equal? Yeah, x plus 3 over 7, right? Okay, so this is 3 times x plus 3 over 7 minus 7. So everywhere I saw g of x, I put in x plus 3 over 7. Okay, I'm going to keep going. That's going to give me, I'm going to go ahead and distribute that 3 on the top, because remember, guys, this is really 3 over 1 times x plus 3 over 7. So top times top, bottom times bottom. So that's going to be 3 times x plus 3 over 7 minus 7. Okay, that's going to give me 3x plus 9 over 7 minus, now I know I'm going to have to put those together. Well, this is 7 over 1. If I need a common denominator of 7, that means I got to multiply both the top and bottom by 7. So that's really 49 over 7. And think about it. 49 divided by 7, that's 7. Okay? So that gives me 3x plus 9 minus 49 all over 7. And so I get f of g of x is going to equal 3x minus 40 all over 7. Well, what did I need it to equal? I needed it to equal x for them to be inverses. Well, since it doesn't, I can stop right here, okay? They're not going to be inverses. I mean, even if you go over and do g of f of x and it equals x, they're still not going to be inverses. That's the stipulation. Both of them have to equal x, okay? So we can say since f of g of x does not equal x, then these functions are not inverses. Okay? Okay, now you notice we've been going, okay, here's a function, find its inverse. Okay, now just because the original thing that we start with is a function, it's going to have an inverse. Every function that we have, every equation that we have, we can find an inverse for it. But that doesn't mean that its inverse is a function. You can have a function and its inverse not be a function, okay? So just because an equation is a function does not mean that the inverse will be a function. Okay? To determine if an equation is a function, we use the vertical line test. On its graph. Right? Like I would give you a picture and I'd give you a graph and I would go, okay, is that a function? And you would use the vertical line test. And if it hit more than one time, you would tell me, nope, it's not a function. To determine if the inverse is a function, we use the horizontal line test. Okay, so normally we have a picture, we have a graph, and we go, okay, is this a function? And you use a vertical line test and you go, yep, sure is. And guys, how do we find the inverse? We switch x and y. Okay, well, going from vertical to horizontal is pretty much a switch. So you can take that same graph, the original graph, and go, okay, well, I want to determine if its inverse is a function. And in order to do that, use a horizontal line. And if it hits that horizontal line more than once, then its inverse is not a function. Okay? It still has an inverse. It's just the inverse isn't a function. Such as if we have f of x equals x squared. Okay? This is our parent quadratic function. He looks like this. Some of you will remember I got negative 1, 1, have 0, 0, I have 1, 1. Okay? And I'm going to go ahead and list these points on here, these 3 points. So you can see what we have. We have negative 1, 1. We have 0, 0. And we have 1, 1. Okay? Now, I could draw a vertical line just like this. Okay? And I know right here, it only hits one time. So, this f of x is a function. Okay? So what my rule tells me up here is if I draw a horizontal line, and I'm just going to do a horizontal, like right here, where I'm hitting both those points. If I draw a horizontal line, what happens? It hits twice. Okay? So that tells me that the inverse of f of x is not a function because it fails that horizontal line test. Okay? Now, I'm going to go ahead and kind of prove to you why, because all I've done is tell you, oh, draw a horizontal line on there. If it hits twice, its inverse isn't a function. And you're going to believe me because you're going to get the problem right and we're going to move on. But here's why, guys. The inverse of f of x is really, inverse of f of x is plus or minus the square root of x. Okay? Over here, we had the points. We had the point negative 1, 1, 0, 0, and 1, 1, right? Okay? Well, when I go to graph its inverse, what do I always tell you to do? Switch x and y. So I'm going to switch those points. I'm going to switch the x and y on those points. So if I have x and I have inverse f of x, that means those points are going to turn into a 1, negative 1, a 0, 0, and a 1, 1. Okay? All I did was switch the table. Right? All I did was switch the values in the table. So I have the point 1, negative 1. I have the point 0, 0. And I have the point 1, 1. And when I go to graph that, what it's done is it's turned that parabola on its side. Okay? And if you'll notice, that means now if I do the vertical line test on this function, what happens? Or not function, on this equation, on this graph, I show that this inverse, this graph, is not a function. Okay? That's why the horizontal line test works. You've switched the x and y, is all you've done. So, if it hits that horizontal line 2 times, that means the 2 new x's, when I've switched them around, they're going to occur twice. So it can't be a function because x is repeating, okay? All right, let's look at example 3. They're not going to ask you to prove anything like that. I just wanted to show you. They're going to give you something like this. Is the inverse a function? Okay, and they're going to give you a picture. And it's going to look something like, it might look something like this. This is actually a quartic function. That means a degree 4 function. It's to the 4th power. F of x equals x to the 4th plus some trailing things after that. I know that because it makes a W. It hits the x-axis 4 times. So it has 4 zeros. Has 4 real roots. Okay. So it is a function. Is the inverse a function? Is the inverse going to be a function? All we got to do, we got to draw a horizontal line. And you tell me, does it hit the horizontal line more than once? Yes. 1, 2, 3, 4. Okay. So that tells me that the inverse of f of x, that of course if this is f of x, then its inverse is not a function. This would literally turn on its side just like the parabola did, and you'd have a W on its side. Okay? Same shape, just turn sideways. Like if you took the if I took this and I copied and I pasted and I turned him like that. Can you see it? Did it pop up there? Okay. That is his inverse. And you see that horizontal line turns into a vertical line. Okay. I'm going to delete it so it doesn't confuse anybody. Okay, let's look at example 4. Let's not write in red like I'm angry. Graph the inverse function. Okay, so they're going to give me just an original graph. They're going to give me f of x, and they're going to tell me to find the inverse of f of x. So f of x itself might be, we might have a point at -3, 0. Okay, then we've got a point at -1, 2. Then we have a point at 5, 3. Okay? And we want the inverse function. So the easiest way to do this is we start off, we just list those points, kind of like I did when I was drawing that parabola a while ago. You list what points you have. You have -3, 0. You have -1, 2. And you have 5, 3. Okay? Now, when I get ready to find that inverse table, well, what did we do to find the inverse equation? We switched x and y, right? Switch x and y, we solved for y, the new y, and then we turned it into f with the little -1x, the inverse of f of x, right? We're going to do the same thing here, except there's no equation. All you got to do is switch the points. Okay, so -3, 0 becomes 0, -3. -1, 2 becomes 2, -1. And 5, 3 becomes 3, 5. Now you plot them. I've got 0, negative 3. I've got 2, negative 1. And I have 3, 5. So now, I have something similar to this. And this is my inverse of f of x. Okay. I'm going to pause that.